Topic 15, video D. Who would like to try question number 1? Jonas? Close, but you're missing one crucial thing. Donna, would you like to try to find the missing component?
Sure.
Good, good.
That's my answer.
Donna, would you like to explain the first step?
Okay, so first I found the grams of carbon in CO2 because you know that all the grams in CO2 comes from the compound CHEMINOZ. So I got 0.079 grams of carbon, and then you want to convert that to moles by dividing by 12 grams, which is the molecular weight of carbon, to get 0.00658 moles of carbon.
Good. Jonas, using that explanation, would you like to try to find the moles of hydrogen?
I think I might be able to. So using her logic, I know that all of the hydrogen H2O came from the compound. So what I have to do basically is just find the amount of hydrogen that's inside of the compound, and it came out to about 0.013 moles of hydrogen. Since we have that, now that we have that information, we can easily find the amount of moles for oxygen.
Good, good. All right, so like you said, you can easily find the amount of moles of oxygen by subtracting the total amount that's in this compound by how much carbon you know you have and how much hydrogen you know you have. Once you do that, you will get 0.1068 grams of oxygen. Convert that to moles and you'll get 0.006675 moles of oxygen. Now, we can't keep moles in a decimal form, right? So you need to divide by the smallest number, and then once you do that, you'll find your empirical formula is CH2O.
Okay.
Topic 15, video D, part 2. Jonas, would you like to try it to redeem yourself?
Let's see if I can do it. So I know that if we use CXHYOZ plus O2.
Good.
And that's the answer.
Good, Jonas. Donna, would you like to describe the answer?
Okay.
You go.
Okay. So it's basically like the problem that we did before. So he found the moles of carbon by finding the grams of carbon in here, which he knows is the same amount in here. They have the same amount of grams. So he converted that to moles, which gives you 0.0432 moles of carbon. And then for hydrogen, he did the same thing because he knows that all the hydrogen in water comes from this compound. So he found the grams in that, which was 0.1198 grams, and divided it by the molar mass of hydrogen, which is 1, which gives you 0.1199 moles of hydrogen. And for oxygen, we can't say the same thing because there's oxygen comes up 2 times here, so we don't know how much grams it is. So we take the whole compound, which is 0.9835 grams, and subtract it from the grams of carbon and the grams of hydrogen, because then we get grams of oxygen left over.
Right.
And then we take that and convert that to moles by dividing by the molar mass of oxygen, which is 16, to get 0.021575 moles of oxygen. And then because we want to get whole numbers, we divide by the lowest number. So we get 1, 5.5, and 2, but we see that there's still a decimal point, which is 5.5. Yeah. So we multiply everything by 2 to give us C4H11O2.
Good. Donna.
Yeah?
That explanation was so good. You should become a chemistry professor.
Oh, thanks, but I'm an English major.
Okay, Donna. Have a good day.
Have a good day.
Good morning, students. Welcome to the study of chemistry. This is topic 1, matter, models, and math. Video A, matter and the periodic table. My name is Donna, and I am the voice that will guide you through your journey to becoming a scientist.